Okay, we're ready to go. So we're going to be looking at the appendicular system. So let's start with the shoulder girdle first. We said that what makes the shoulder girdle is the clavicle and the scapula, and how these two bones articulate with the sternum. We leave the humerus bone out when we're talking about the shoulder girdle. So if we look at the clavicle, you'll notice that the medial 2/3 of it is convex and the lateral 1/3 is concave. The medial aspect of the clavicle articulates with the manubrium, this portion of the sternum. So we call this joint the sternoclavicular joint. As we move further laterally, we'll see how the lateral aspect of the clavicle articulates with the scapula. This part of the scapula is called the acromion process. So we call this joint the acromioclavicular joint. What's interesting is that if we find the deepest part of the concavity of the clavicle and we drop inferior, it takes us to another process called the Coracoid process, not to be confused with coronoid. So the coracoid is on the scapula, because there is a coronoid in the mandible and there's a coronoid on the ulna. There's only one coracoid. Okay, so just a quick review on the sternum. We said that we had a manubrium, the body, which is also the gladiolus, and the distal end of it, the xiphoid process. Right, now we're going to look at the scapula. And if you can just hand me the free-floating scapula. One of the first things we have to look at is, how do we know if we're looking at the scapula from the front or the back? And if we look at the front, it's nice and smooth. And when we look at the back, we have this spine of the scapula. So when we look at the scapula, we'll see that we have 3 borders, and those 3 borders are, now if we go here, the vertebral border, also known as the medial border. It's called vertebral border because it's closest to the vertebral column. So that's the vertebral border. We move lateral, that's the lateral border, also known as the axillary border because it's close to the axilla or the armpit. And we have a superior border up on top. So we have a superior border, medial border, and a lateral border. We have 3 angles: a superior angle, inferior angle, and the lateral angle where the glenoid cavity is. We also have 4 fossas. First, let's look at the structure referred to as the spine of the scapula. So this is looking at the left scapula. That's the spine of the scapula. So above the spine of the scapula is a fossa, and below it is a fossa. This is referred to as the supraspinous fossa. This is the infraspinous fossa. When we go to the front, that's the subscapular fossa. So supraspinous fossa, infraspinous fossa, subscapular fossa. On the lateral side, where the head of the head of the humerus would articulate with, that's called the glenoid fossa or glenoid cavity. Notice that the head of the humerus is larger than the glenoid cavity. I like to refer to it as the golf ball sitting on a golf tee, which makes it a very unstable joint. Because it's unstable, we need a lot of soft tissue support there. So the innate intelligence of the body creates quite a bit of ligaments and the rotator cuff muscles to protect it. Okay. Notice that the spine of the scapula starts medial, works its way superior lateral, and becomes the acromion process. We said that the spine of the scapula, if we moved medially, takes you to about the 3rd thoracic spinous process, and the inferior angle as we move takes us to about the T3 spinous process. Just some interesting landmarks. Okay, so I think that finishes the scapula. Let's move to the next bone, which is the humerus. So the first thing we'll have to do is let's make sure that we're in anatomical position. So this is the right arm, the thumb pointing out, supinated, that is anatomical position. So now if we go to the humerus, we have the head of the humerus. We have two tuberosities, a greater tubercle and a lesser tubercle. These tubercles are significant because your rotator cuff muscles will attach here. The supraspinatus, infraspinatus, and teres minor will all insert here, and the subscapularis will insert to the lesser tubercle. Between the two tubercles is a sulcus or a groove, known as the intertubercular groove, also referred to as the bicipital groove or sulcus. And what do you think travels in the bicipital groove? The biceps tendon. Bicep means two, so there's a long head and short head. There's two tendons. It's the long head of the bicep that travels through here. When we move further distally, we get to a deltoid tubercle, a roughened portion here, and what do you think attaches there? The deltoid muscle. We move further distally to the distal end of the humerus, where we get to two epicondyles. The one that's larger and more prominent happens to be on the pinky side. The pinky is medial, which would make this the medial epicondyle, and this the lateral epicondyle. At the distal end of the humerus, we'll have three fossas, two on the anterior, and you can see that one on the posterior. Let's look at the anterior ones first. When the elbow flexes, you'll notice that this bone and this bone will articulate with these two fossas. Let's take a look at that. So as we flex, it'll meet those depressions. So we would need to know, can you see that?
Yeah.
We would need to know, well, what's the name of this bone and what's the name of this bone, because that's going to tell us what these fossas are named. So this bone is the ulnar, and this is the radius. So this is the head of the radius. This is the coronoid process. The coronoid process, when the elbow flexes, fits in the coronoid fossa. The radial head, when the elbow flexes, fits in the radial fossa. When we look at it from the posterior, that's the olecranon fossa, which is where the olecranon process will fit into when the elbow is not flexed, but when we extend it, it fits perfectly. Articulating with the ulna, we have a trochlear, and articulating with the head of the radius is the capitulum. The capitulum and head of the radius, that joint is what allows for this motion, which is rotation of the forearm, which supinates and pronates the hand. It's that round head of the radius articulating with the capitulum that allows for that action. Okay, moving distally, as we go further down, we get to the styloid process of the radius and the head of the ulnar. So isn't that interesting? The head of the ulnar is distally, but the head of the radius is proximal. Then we move to the wrist and we look at the carpal bones. We will divide them into two rows, a proximal row, 1, 2, 3, 4, and a distal row, 1, 2, 3, 4. Moving from lateral to medial, starting with the thumb side, which is lateral, the pinky, which is medial, proximal row first, we have the scaphoid, the lunate, the triquetrum, and the pisiform sits anterior to it. Starting with the distal row, going lateral to medial, we have the trapezium, the trapezoid, capitate, and hamate. And that little hook right there is called the hook of the hamate. Now, in Greek, the word meta means after, so after the carpals are the carpals, being that the thumb is the first